The Chicxulub crater marks the place where an asteroid so enormous hit Earth and wiped out the entire planet's dinosaurs. Scientists thought they knew what happened here, but the full story that's emerging beggars belief. Yes, now experts have dug deep into the massive cavity, and they've finally realized precisely what occurred when the space rock actually struck the Earth. And the team's findings paint a truly terrifying picture. Experts drilled into the crater that killed the dinosaurs and made an incredible discovery. Of course, pretty much everything about the Chicxulub crater is mind-blowing. It stretches 93 miles in diameter, for instance, and plunges a stunning 12 miles into the ground. And of all the known impact points on Earth, it's the second largest in the world. Yet even though the crater appeared about 66 million years ago, its peak ring remains in one piece. This particular detail highlights just how stunning the Chicxulub crater and its long-term preservation has already proven to be. It's the only crater on the planet that has its peak ring still intact, in fact. The next available one for scientists to study sits, rather inconveniently, on the moon. Now, though, scientists have gone beyond the basic topical details of the Chicxulub crater. Digging into the expanse, which sits more than half a mile beneath Mexico's Yucatan Peninsula, experts in fact uncovered the impact that an up to 50-mile white asteroid had on the planet. And it's not a pretty picture. To put the findings in context, scientists investigated the crater's background. So the Chicxulub crater derives its name from the nearby Mexican town of the same name. And experts estimate that an asteroid or comet, ranging in size from 6.8 to 50.3 miles in diameter, smashed into the Earth at this very spot. It's hard to imagine such a massive piece of space debris hurtling in the direction of our planet. But perhaps even more stunning is the abyss it left behind. The Chicxulub crater has an estimated diameter of 93 miles. For reference, that's just 1.6 miles shorter than the drive between New York City and Philadelphia. Experts have been able to calculate the strength with which the space rock smashed into the Earth, too. They estimate that the asteroid or comet had 21 to 921 billion times as much energy as the atomic bomb dropped on Hiroshima in World War II. Even the Soviet Union's Tsar Bomba, the strongest human-made explosive to ever detonate, couldn't compare. The solar system body also released 100 million times the energy of Tsar Bomba upon impact. So with that much power hitting the Earth, the size of the Chicxulub crater makes sense. It's not just its width that's extra large, either. The crater reaches depths of up to 18.6 miles into the planet. These dimensions make the Chicxulub crater the second largest impact crater on Earth, just behind the one near Vredefort in South Africa. But the Chicxulub crater has one feature that no other known crater on Earth has. It's a peak ring crater. This means that the impact site has no single central peak. Instead, the crater has a circle-shaped plateau encompassing its center. The rim of the crater encircles this ring, but it sits at a distance from the center. Marine geophysicist Sean P.S. Gulick explained to the New York Times in 2016 just how rare the peak ring feature is. He said, "Chicxulub is the only crater on Earth with an intact peak ring that we can go sample its ground zero of the Cretaceous extinction event." And yet scientists haven't necessarily rushed to dig into the Chicxulub crater. That was partly due to the fact that the massive hole appeared approximately 66 million years ago. So over time, rocks and water have filled the void, and now more than half a mile of sedimentary rock covers the crater. Also, scientists didn't discover the Chicxulub crater until relatively recently, especially considering that it has been around for millions of years. It wasn't until 1978, in fact, that geophysicists Glenn Penfield and Antonio Camargo stumbled upon the crater. And they weren't even looking for the asteroid impact site when they discovered it. The pair were searching for petroleum. So Penfield and Camargo took to the skies to complete a magnetic survey that mapped any potential drilling locations beneath the Gulf of Mexico. As he pored over the resulting data, though, Penfield noted something particularly extraordinary. A 40-mile white underwater arc with impeccable symmetry. Such a strange discovery inspired Penfield to dig deeper. He then sought out a gravity map commissioned by his employer, oil company Petróleos Mexicanos, in the 1960s. On it, Penfield noticed another arc, but this one curved over the Yucatan Peninsula itself. And when the geophysicist put that map and his magnetic survey together, he realized that the two arcs made a circle. Penfield knew almost immediately that he had found something spectacular. The geophysicist hypothesized that he had pinpointed a cataclysmic event in the planet's geological history. Petróleos Mexicanos then allowed him and Camargo to present their findings at the 1981 Society of Exploration Geophysicists Conference. Unlike the asteroid they theorized had hit the Earth, though, their presentation made little impact at the time. So eventually Penfield gave up on his research into the crater. Much of the evidence that he had sought was even destroyed or lost. Nevertheless, Penfield published all of the data he had and returned to work. Yet other scientists had begun to theorize something similar without having seen Penfield's research. Specifically, in 1981 a graduate student at the University of Arizona named Alan R. Hildebrand and his advisor William V. Boynton published their own Earth impact theory. They just needed to find a crater that could corroborate their hypothesis. The pair had plenty of geological evidence, though, and their work got a bit more traction than Penfield's. Namely, a professor in Haiti named Florentine Moraz uncovered evidence that an ancient volcano had once stood in his country. Hildebrand consequently realized that it could have emerged after a major force of impact crashed nearby. And in 1990 he learned the precise spot of such a collision. In that year, you see, a reporter for the Houston Chronicle named Carlos Byers clued Hildebrand into Penfield's findings. The journalist also mentioned that the geophysicist had thought he had found an impact crater in the vicinity. So Hildebrand picked up the phone, and the two experts later started analyzing drill samples from the oil company's storage unit. What Penfield and Hildebrand found amid the drilling debris were shock metamorphic materials. Such substances appear after an impact-related event causes deformation and heating. In normal cases, shock metamorphism occurs along with a volcanic eruption, but, of course, Penfield and Hildebrand had uncovered something much bigger than that. And researchers who drilled in the Chicxulub crater in 2016 found that the impact at the site seemed to have disrupted the usual layering of rocks. Granite, which would normally sit miles beneath the Earth's crust, had been relocated to the surface. Since then, more research into the Chicxulub crater has transpired, and more theories about its origins have arisen. In September 2007, for instance, authors William F. Botke, David Vikrowlicki, and David Nisvorny offered a theory to Nature magazine. The trio said that the rock responsible for creating the crater came from a specific cosmic family called the Baptistina asteroids. Yet in spite of facts that seemed to corroborate Vikrowlicki, Botke, and Nisvorny's theory, new evidence released in 2011 negated their claim. What came to light? Well, researchers had pinpointed the Baptistina asteroid family's formation to around 80 million years ago. This would make it nearly impossible for the space rock to reach Earth when the Chicxulub crater formed 66 million years ago. That's because it takes multiple tens of millions of years for asteroids to collide and resonate. But the discovery of the Chicxulub crater also lent credibility to a theory first formed by physicist Luis Alvarez and his geologist son, Walter Alvarez. Both men believed that between the Cretaceous and Paleogene periods, a massive impact on Earth had triggered a series of animal and plant extinctions. And among them were all of the non-avian species of dinosaurs. Some of the Chicxulub crater's statistics do apparently fall in line with the Alvarez theory too. For one thing, the initial dating of the crater estimated its formation happening about 66 million years ago. So this timing would have the asteroid or comet slamming into Earth just between the Cretaceous and Paleogene periods, just as the father and son duo suspected. Many people also subscribed to the Alvarez theory about the Chicxulub crater. Specifically, the idea that the impact that caused it also triggered a mass extinction of, among other species, land and sea-dwelling dinosaurs. Yet so much mystery surrounded the enormous undersea divot. So scientists had to drill into it to learn more. And in 2016 it finally came time for such an excursion. Marine geophysicist Gulick and geophysicist Joanna Morgan helmed a crew of over 30 who represented a dozen different countries. The researchers boarded a boat and sailed into the Gulf of Mexico. And there, they transformed their vessel into a drilling station. The drilling station stood tall on 3 legs, rising about 40 feet above the Gulf of Mexico's turquoise waters. The team then drilled incredibly far into the Earth. And after the tool delved 60 feet underwater, it met the rock below and continued to dig a stunning 2,000 feet into the crust. Of course, over a 66 million year period, the Chicxulub crater had filled with a sizable amount of limestone and sediment. But the scientists' machine worked its way past the new collection of rock to find what they were looking for. The material that made up the planet's only peak ring crater. Gulick, Morgan, and their team actually discovered that granite made up the peak ring. Normally, this variety of rock is found far deeper in the Earth's crust than it appears in the crater. This means that the asteroid had such an incredible impact that it had pushed sediment from miles beneath the surface all the way to the top. Geophysicist Morgan, who works for Imperial College London, told the New York Times these rocks behaved like a fluid for a short period of time And rocks don't tend to do that. It's a very dramatic process when you form a large crater. Apparently, this reaction gave credence to something called the dynamic collapse model theory. The dynamic collapse model theory hypothesizes that the asteroid's impact pushed rocks deep into the Earth's crust before forcing them back up and out of it. Then these rocks collapsed down again and settled to form the crater's peak rings. And the fact that granite forms the crater's central plateau apparently goes hand in hand with such a theory. But drilling into the Chicxulub crater revealed more than one truth about this devastating geological event. The rocks also told the story of what had happened once the asteroid had smashed into the Earth. Scientists revealed this evidence in 2019. And the picture they painted of the world post-impact was a terrifying one, to say the least. Gulick said he and the rest of the scientists could be so specific with their findings because they had an unprecedented amount of rock to work with. He explained to the New York Times, "We normally get to read rock records that give us centimeters per 1,000 years. We have 130 meters for a day." The rocks told a story that goes like this. First, an enormous chunk of cosmic rock slammed into the ground, instantly creating a crater 60 miles wide and 20 miles into the Earth. The initial impact created waves in the nearby Gulf, quite literally. A tsunami formed, in fact, charging away from the new crater. The asteroid's impact also sent huge pieces of rock hurtling into the air, as far as the planet's upper atmosphere, and likely beyond even that. Gulick theorized that almost certainly some of the material would have reached the moon. Yet the largest bits flew up before crashing back down on the ground, still hot from the initial impact. Some smaller pieces of hot rock took longer to fall and had more time to cool. These geological wonders, called tektites, scattered across what is now the North American continent. Then water started rushing back into the crater after it waved outward. But refilling the geological depression would be tame compared to the next stage. When the asteroid collided with the Earth, you see, it created a tsunami. And of course, water ebbs and flows. So, soon enough, those powerful waves returned back toward the crater. Multiple massive tsunamis with waves towering hundreds of feet in the air then came back over the gaping geological hole. The rush of back and forth tsunamis quickly filled the peak ring with a 4-inch coating of sand and gravel. And as the Gulf raged, the land close by was also ravaged. The asteroid's impact had, for instance, sparked wildfires across the area. Scientists know this because they pinpointed pieces of charcoal in the peak ring just above the tsunami sediments. These wildfires could have started from the asteroid's scorching thermal energy upon impact. The aforementioned shower of molten rock could have had something to do with it, too. In any case, Gulick told the New York Times, probably not everything burned, but certainly there were global wildfires. So altogether, the tsunamis, falling rock, and fires wiped out a stunning number of Cretaceous-era species. It's hard to believe that scientists could conjure such haunting images from layers of rock hidden deep beneath the Yucatan Peninsula. Yet for planetary geologist Paul Byrne, the Chicxulub crater's layers make palpable some long-standing scientific theories. He told the New York Times that it was one thing to develop and simulate such hypotheses, but it was quite another to see it. And the days of asteroids striking Earth to devastating effect are far from over. Researchers were scanning the night sky when all of a sudden, something shot across the darkness that left them completely stunned. It seemed to be an object passing through our galaxy worryingly close to Earth. But there was something even more disturbing to them about this scene. The experts had spotted this mysterious traveler using a special telescope, a device designed to detect space objects that could be existentially dangerous to our planet. And unfortunately for all of humankind, it appears this unidentified item could definitely pose a threat. Luckily, one man was on the case. A couple of days after the object was first spotted, Paul Chodas set to work studying this enigmatic phenomenon. And if anyone could get to the bottom of it all, it would be Chodas. As the manager of the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory in Pasadena, Chodas seriously knows his stuff. At this point, though, the exact identity of the object remained anybody's guess. Was it an asteroid or a random lump of space junk? How about an alien spaceship from another galaxy? Okay, that third option was, to say the least, a bit of a stretch. But it couldn't be discounted entirely. At this early stage, scientists had no ready explanation for this unusual vision in the night sky. What was already emerging, however, was that the object was acting in ways not normally seen by your standard asteroid. That's what Chodas noticed, anyway. Usually, an asteroid follows a path through space that is tilted in relation to the orbit of the Earth around the Sun. By contrast, this particular body was on the same plane as our planet's path. Another peculiarity was that 2020 SO, as the object came to be known, was not traveling through the heavens at the type of speed normally observed with asteroids. It was progressing at roughly 1,500 miles per hour, much more unhurried than usual. So, Chhota was finding it less and less likely that this was actually an asteroid. But if that was true, then what exactly was this strange visitor? That speed or lack of it was a clincher, as close passes of the Earth by asteroids are not unusual. Asteroids, in case you need reminding, are lumps of rock that may have traveled through space for millions or even billions of years. In fact, they're what remains of the formation of the solar system, the sun and the planets around 4.6 billion years ago. That's pretty neat to think about. And according to NASA, there are more than 1 million asteroids in the solar system. But don't be fooled by that impressively high number. If you took all of these bits of space rock and melded them together, you'd end up with a mass that only comes in at less than half the size of our moon. Where are most asteroids found? Generally, in a region lying between the planets Mars and Jupiter. And it's fortunate that this belt is so far away. Here, you see, you can find the asteroid Vesta, which is a whopping 329 miles around. Good job it isn't any nearer to Earth. But with that said, most asteroids typically span only around 30 feet or so. And when one of them enters the Earth's atmosphere, it usually burns up to become a meteor. But we should be more worried about meteorites, as they partially survive their descent through our atmosphere and strike the Earth. The best known meteorite was the one that hit our planet roughly 66 million years ago, and the consequences of its impact ultimately led to the extinction of the dinosaurs. So, although most meteors or meteorites are harmless, not all are. And that's why the Center for Near-Earth Object Studies exists. You'll remember that this agency's boss, Chhota, was the man who recognized that 2020 OS did not seem like an ordinary asteroid. As you'll recall, however, he wasn't at all sure what it really was. In any case, the organization Chhota heads has a very important mission. Staff at the agency keep an eye on the skies, and when they spot an asteroid, they make an assessment of the object's likely trajectory. Yep, if Earth is going to be struck by a dangerously large piece of space rock, it's the Center for Near-Earth Object Studies that will sound the warning. But could there be another explanation for the object the Hawaiian researchers spotted? Well, yes. Simply put, it could be space junk. According to the UK's Natural History Museum, thousands of pieces of space debris have been left to orbit around the planet since humans first started looking to the skies. Bits of launch rockets and even just fragments of paint are all traveling around in the atmosphere, along with what is said to be around 3,000 redundant satellites. And there are literally millions of smaller bits of trash traveling in circles, trapped by the planet's gravitational pull. Generally speaking, abandoned or lost pieces of equipment that are left at lower altitudes soon burn up in the atmosphere as they're pulled towards Earth. Pieces of junk at more than 22,000 miles above the planet's surface, however, will remain in pointless orbit for centuries or even millennia. And, shockingly, new satellites could even collide with old dead ones, although it's roughly a 1 in 10,000 chance. Then, when India, the USA and China use these redundant satellites for missile target practice, another wrench is thrown into the works. You see, the resulting impact and explosion of one of these launches create thousands of bits of extra garbage. And while space junk might seem a fairly remote problem, it's a real one. In 2020 alone, the International Space Station had to take evasive action on at least 3 occasions to avoid collisions with this detritus. Plus, as you may already have assumed, this mysterious object sadly wasn't an alien spaceship. So, what exactly was it? Well, the evidence began to point in one rather surprising direction. Chhota had already ruled out an asteroid, of course, because of the way this mass was orbiting around the Sun and the Earth. Specifically, Chhota had discovered the unusual path 2020 SO was taking after using a computer simulation. But it was then that he had a bright idea. Why not try throwing the simulation into reverse in an attempt to work out the origin of the object? And as it happens, that's just what he did. In effect, Chhota was making 2020 SO travel back through time, and the results were startling. You see, this backward simulation showed that the object had been quite close to Earth back in 1966. In fact, as the scientist told the New York Times in December 2020 SO was close enough that it could have originated from the Earth. With this incredible news in his back pocket, Chhota quickly went public. He emailed colleagues around the world with a message describing the hunch generated by his backward simulation. The gist of this theory? He believed the mystery object could actually once have been part of the NASA Space Vehicle Surveyor 2. And that seemed a real possibility, as the Surveyor 2 mission had gone spectacularly wrong. This doomed launch had actually been part of NASA's Surveyor series, with the first blast-off from Cape Canaveral being in May 1966. And the program had gotten off to a good start. Powered by an Atlas Centaur rocket, the Surveyor 1 spacecraft made the first ever successful soft landing on the surface of the moon. The purpose of the Surveyor missions was to scout out conditions on the moon for the manned Apollo missions that would follow. So, as Surveyor 1 had done its job well, NASA was apparently optimistic about its second Surveyor mission, which launched in September 1966. Like its predecessor, which had transmitted 11,000 images back to Earth, Surveyor 2 was tasked with beaming back photographs of the lunar terrain. Mike Dinn had been the deputy director of the monitoring station in Tidbinbilla, Australia, that had tracked Surveyor 2 as it sped towards the moon. And when speaking to the New York Times in December 2020, he recalled the positive mood that had surrounded that 1966 launch. Dinn claimed, "We fully expected Surveyor 2 to be a complete success. It's true that Surveyor 2's launch went smoothly. Like Surveyor 1, the 1-ton spacecraft was blasted into space en route to an area of the moon called Sinus Medii. But at a critical moment in the flight, something went very wrong with one of Surveyor 2's 3 booster engines. NASA's plan was that the 3 thrusters would all fire for just under 10 seconds during the journey to the moon. This would correct the course of Surveyor 2, ensuring that it would land at the chosen destination. But while 2 of the jets ignited as planned, 1 remained dead. And, unfortunately, this failure pushed the ship into an uncontrolled tailspin. Desperately trying to correct the malfunction, ground control at the mission center tried to fire up the uncooperative rocket again and again. But it was all to no avail. The spacecraft lost communication with Earth and began to freefall towards the moon's surface. A NASA press release just after the event described what had happened next. The somber message revealed, for more than 24 hours, engineers at the Jet Propulsion Laboratory attempted to correct an out-of-control tumbling condition, which began during the mid-course trajectory correction of Surveyor 2 early today. It also was apparent that the major objectives of the mission could not be met. Ultimately, the stricken spacecraft crashed into the moon's surface, near the crater Copernicus. Still, this catastrophe didn't stop NASA from continuing with the Surveyor program. And, fortunately, of the 7 launches, 5 all passed off without major incident. It all culminated in the Apollo 11 mission, which landed men on the moon in 1969. This truly history-making feat was partly enabled by the information that the Surveyor spacecraft had previously collected. Overall, the Surveyor program had proved more than worthwhile. But that didn't help Chodas. Even though he had an inkling that the mysterious object had been part of the Surveyor 2 rocket, he needed to make sure once and for all. Detailed analysis of 2020 SO was the next step. Scientists around the world then began to work on studying this strange flying mass, hoping to get a positive ID. Of course, that was no easy task. We're talking about something that was only about 25 feet long, after all. It also didn't help that it was floating through space many thousands of miles from Earth. But there was confirmation of sorts that 2020 SO was not a naturally formed asteroid. Researchers in Arizona and Spain confirmed that radiation from the sun was subtly altering the object's path, which would be extremely unlikely if the mass was a piece of solid rock. If it was a hollow piece of metal, on the other hand, that phenomenon would be entirely expected. So, it was looking increasingly likely that 2020 SO was not an asteroid or even an alien spaceship, but the remains of a booster rocket. And Chodas suggested that it could be the Centaur rocket section from Surveyor 2. That had been jettisoned soon after the spacecraft had launched from Earth. After separating from Surveyor 2, the Centaur booster had traveled on through space, past the moon, and as far as anyone knew onwards into oblivion. But if this piece of space debris was the Centaur, it had clearly started to orbit around the sun in a full circle that also brought it close to Earth. Fortunately, state-of-the-art technology was able to help confirm that 2020 SO was comprised of metal rather than rock. Vishnu Reddy, an associate professor at the University of Arizona's Lunar and Planetary Laboratory, led the team that analyzed the data captured by an infrared telescope in Mauna Kea, Hawaii. Quoted on the NASA website, Reddy said of the results, due to extreme faintness of this object following the Center for Near-Earth Object Studies prediction, it was a challenging object to characterize. We got color observations with the Large Binocular Telescope or LBT that suggested 2020 SO was not an asteroid. But his work went further than that. Next, Reddy and his colleagues compared the infrared signature of 2020 SO with that of 301 steel, the material used in Centaur rockets. But while the match was close, the team had to be even more precise if they wanted to make a definite identification. So, they went on to the next stage of the painstaking research, which involved more infrared signal comparisons. Reddy explained this further step, saying, "We knew that if we wanted to compare apples to apples, we'd need to try to get spectral data from another Centaur rocket booster that had been in Earth orbit for many years to then see if it better matched 2020's spectrum. But this, too, would be no simple task. Because of the extreme speed at which Earth-orbiting Centaur boosters travel across the sky," Reddy continued, "we knew it would be extremely difficult to lock on with the infrared telescope facility long enough to get a solid and reliable dataset. But the scientists were determined to do just that. And early in December 2020, they succeeded. The researchers focused on observing what they knew to be the remnants of a Centaur booster rocket from 1971. They kept this piece of space junk in their sights long enough to get sufficient data, as that way they could compare this information with what they already had about 2020. And the result of the analysis of the two sets of data? A match. Yep, what had started out as a mere hunch was now accepted as fact. This piece of space junk definitely was not an asteroid. Nor was it a spaceship from another galaxy, even if UFO hunters may have wanted it to be. Instead, it was indeed the Centaur booster rocket that had formed a key part of the sadly unsuccessful Surveyor 2 mission. Sometime around the spring of 2021, the Centaur booster will pass beyond our planet and head off on its orbit around the sun. And it won't be the last time that this memorial to the failed NASA launch returns. The dead thruster is slated to head again towards Earth sooner than you may think, in fact. Chodas told the New York Times, in 2036, it's coming back. Thanks for watching, and don't forget to like and subscribe.